All right, so today should be a fairly simple lecture, nothing too complicated. We're just going to cover repetition structures in Python, which are known as loops. And Python gives you only like two ways to actually do the loops. It's only a while loop and a for loop, so it's really simple. You just need to know the difference between the two. And that is what we're going to cover today. All right, so a little recap about what loops are, even though you are already familiar with them from Java. However, why would we use loops? Well, because we don't want to duplicate our code too many times. And if we have some sort of code that needs to be duplicated, we would rather use a loop because this is exactly what they're made for. They're called repetition structures, and they're just going to repeat your code as many times as necessary for your program. And these are all of the let me see. All right. There are only two kind of like broad categories, two general categories of loops in Python. They're called either condition controlled loops or count control loops, and it's in the name. So the condition controlled one tests a certain condition for true or false, and then it executes for as many times as that condition is true or false. It depends. And the other one is just going to repeat as many times as you need them to repeat themselves. So basically, you're going to specify a certain number that that loop is going to go for, and that is exactly the amount of times that it's going to execute. So the first one that we're going to cover is called a while loop. And the while loop, you are familiar with it. Just in Python, it's a little bit easier to write it. It's a little bit easier to understand what it does and to see what it does than in Java, in my opinion. And this is the format. So you're going to put the keyword while, then you're going to test some sort of condition for either true or false. After that, you're going to put your colon and whatever you want to execute in between your program, and you're going to put it indented by a certain amount of spaces. Usually it's just you press tab, but whenever you're going to be doing your assignments, the indentation is going to be done automatically for you. All right, let me get this smaller. All right, so this is the logic of a while loop. This is what it looks like in a flow chart. So basically, we come in, we we check some sort of condition right here in this row shape structure. We check for some condition. Then if it's true, then we're going to execute some sort of code, and we're going to come back all the way back to the beginning, and we're going to test our condition again. However, if this condition at some point executes as false, we're just going to exit our loop, and we're going to stop executing that loop. Nothing too complicated. However, you need to know that for that loop to stop executing, something needs to happen inside of your loop. So some sort of action needs to happen, so your condition will turn to false, the one that you're checking. Otherwise, your loop is going to be an infinite loop, and it's going to be running for forever. And we don't want that. We don't want to have infinite loops. Now, a little recap, what we call iteration is a term for just one execution of your body of the loop. So execution of one loop is called one iteration. And one thing also you need to know that a while loop is known as a pre-test loop. And what that means is that we're going to test the condition before any code is executed. That's all it means. So there are pre-test loops and there are post-test loops. The post-test loops, they check for the condition after the iteration of your loop. So the while loop is a pre-test loop. So it's going to check for your condition first. If that condition is false, your code will never be executed. That's why it's called the pre-test loop. All right, here is a little flow chart for just to show a loop. And let me show you. So it starts right here. Then we assign y to some variable called keep going, and y stands for yes. And then we check the condition. If keep going equals y right here, then we're gonna move forward with the true arrow, and then we're gonna do some sort of action right here. So we're gonna ask the user a couple of things, then we're gonna multiply, like do some calculations. It doesn't really matter, but all of these things are inside of your loop. All of this is inside of your loop, and then we're gonna go all the way back and check if that keep going is still y. If it's not, if it's something different, then we're just gonna exit our loop and we're gonna end our program. So this is all that this flowchart is showing you. Now, as I mentioned before, infinite loops. So, oh, never mind. While loop. One sec, I'm a little bit lost in where I'm going with my new mouse. Okay. Yes, so you can also use your while loop as a count control loop. So as I told you before, while is generally a condition control loop. However, if you want to use it as a count control loop, you're very welcome to do so. However, you have to use some sort of variable that's going to keep that count running for you. That's going to keep the count of each iteration of your loop. And that's what we call a counter variable. And it just stands for counting how many times your loop has ran. The only things that your count control variable should perform is the initialization of your controlled variable, so of your counter variable. You have to start with some sort of number, right? You have to start either at 0 or at 1. It doesn't matter at what point you're starting, but you have to start somewhere. You have to create that variable. That's what it means by initialization. Then you have to compare that variable to some sort of other number that's going to mean the end of your loop. So you have to compare whatever value you assigned right here in the first stage. You have to compare it to some sort of ending value to determine wherever your loop needs to end. And then at the end, after that, the last step is your loop needs to update your counter variable. So if you keep that counter variable the same throughout the whole iteration of your loop, then nothing's going to happen. Your loop will just keep running and you're going to end with an infinite loop. And again, we don't want that. Here's an example of a while loop used as a count control loop. So this is the initialization part right here. We assign n to let me see. We assign n to 0 right here. So we initialize our variable n to 0. And then in our while loop, what we have is we're comparing n to the number 5. So as long as n is less than 5, our loop will keep running. And then we're going to just print inside the loop the value of n is and whatever that value is. After that, we are updating our value at the very end. We are just adding 1 plus 1 to each time our loop iterates. We're adding +1 to n. So all that this loop is going to do is going to print inside the loop the value of n is, whatever the value is. In this case, it's going to be 0. Then it's going to be 1. Then it's going to run 2, 3, 4. And after 4, we're going to come to here and our n is going to be equal to 5, right? Because we add 1 to it. So it's going to equal to 5. And then when we come back and test our condition again, this condition will be false and our loop will stop executing because n equals 5 is going to be more than 5, basically, because our comparison right here is only strictly for n is less than 5, not n is less than equal to 5. So our loop will stop iterating after it reaches 4. All right. You can also put your while loop on one line, everything on one line. It's called single line while loops. And if you don't do anything else with your loop, you can use this way of writing your while loops. And in this case, look at this one. We have our initialization n equals 0. Then we have our while loop n is less than 10. We're just going to add 1 to n. So this loop doesn't print anything. It doesn't do anything. The only thing that it does is adds 1 to n after each iteration of your while loop. So after n it reaches 9, this loop will stop executing. All right, moving on to the count controlled loop, the for loop. And you probably saw it in Java already. However, here it works a little bit different in Python and the general format is a little bit different. But all you need to know about the for loop is whenever you want to use your for loop, you will usually use it with some sequence of data items. So either you're going to iterate through an array or you're going to iterate through your lines in a list. So it just depends. And this is the general format. So what you're going to do is you're going to put your keyword for, then you're going to put for whatever variable you want to check in is the keyword in, and some sort of sequence. So in this case, this is an array of values, value 1, value 2, and etc. So you're going to use that for loop to check for variables in some sort of sequence, and then whatever you want to execute inside of your code. All right, as you can see here, what's happening, we're checking our loop for each number in an array of 1, 2, 3, 4, 5. And then we're just printing that number. So what's going to happen during our first iteration, we're going to print 1. So this iteration right here, it's going to print 1 because it is the first number right here. Then the second iteration is going to print 2 for us, and so on. This one's going to print 4, 3, 4, and 5. So nothing too complicated. The only big difference is that you're using your for loop with a sequence of data, and you're using your while loop when you want to test a true or false condition. There's also such thing called range, and a range is a pretty useful function in Python, and what it does is just going to simplify the whole process of writing your for loop. So range is going to return an iterable object, and what that means is going to return to you a sequence of numbers or a sequence of values that you can iterate through. So you can go through them each one by one. And range has some certain characteristic to it. And if you use range with just one argument, and I'll show you an example of it in a little bit, if you use range with just one argument, that just used as an ending limit. So you're just specifying that you want to go from 0 to whatever that ending limit is. Then if you use two arguments, that means that you're specifying the starting value where you want your range to start and the ending value where you want your range to end. And if you use three arguments, the third argument is used as a step value. And what that means is you're specifying by how many numbers you want to increase each time when your loop iterates. So I'll show you that in a little bit. That might be a little bit too hard to grasp right now. Okay, target variable, we don't need to cover that. Sometimes you can also let the user control the loop iteration. So you can ask the user how many times the loop needs to run, and they will specify that number for you. And then you can use that number later in your program, because sometimes you don't know how many times the loop needs to run. It may depend on the user. So that's why you might want to use an input statement to get some input from the user. All right, generating an iterable sequence. Yeah, so this is what I wanted to show you, how range works. So the first value that we have right here is the starting value. So we're going to start at 10, and then we're specifying the ending value. The ending value is 0. So we want our loop to run from 10 to 0, and this is the step value. So we're specifying by how much we either need to increase our value or decrease. If it's negative value, we want to decrease our starting value. If it's positive, we want to increase our starting value. So in this case, what this range gives us is going to give us 10, 9, 8, 7, and so on up until 0. So this is what is going to be returned. It's just going to be returned as a list of numbers from 10 to 0. You can also calculate a running total of a series of numbers. And usually when you do that, you have to either include a loop that's going to read each number in your series, and then you need to run an accumulator variable, and that's just a fancy word for your total. So you just have to keep that total running, and that needs to be always present in your loop. Let me show you an example of that with a flowchart. So we are setting our accumulator to 0. And then after that, we are asking, is there another number to read? Is there another number in the sequence? If it's yes, which is going to evaluate to true, then we're going to read that number, and we're going to add that number to our running total. So for example, if we have a range of numbers from, let's say, 1 to 3, right? We have a range of numbers, and then we have our accumulator to 0. And then we're checking, do we have another number to read in our sequence? Well, yes, we have our 1. Then that 1 is going to be added to 0. So we're going to have 0 plus 1. Now our accumulator equals to 1. Then we're checking, is there another number that we can read from our sequence? Yep, we have number 2. And then we're going to add that to whatever we have in our accumulator. And we had 1 in our accumulator. So now our accumulator, instead of being 1, it equals to 3. Then we keep going. Is there another number to read? Yep, we have another number right here. We have number 3. And then our last step is adding that number to our accumulator variable. So in this hypothetical scenario, our accumulator at the end is going to be equal to 6. So this is how you would calculate a running total of whatever you need to calculate. All right, another very useful thing is called augmented assignment operators. And these are all, it's just easier to show you the example. They're called also sometimes shorthand operators. And this is what they look like. So the operator, as you can see, we combine plus and equal sign, or either minus and equal sign. We combine something with the equal sign. And here's an example of that. We have x plus equals 5. I know it might look a little bit weird, but you get used to it, and it's just way easier than retyping your variables over and over again. And this statement right here, x plus equals 5, is equivalent to x equals x plus 5. So whenever you need to do some sort of calculations to the same variable, you can use these augmented assignment operators. So all they do, they just simplify your code. They just simplify, the way you write your code. So it's another useful thing to know. Now, Sentinel. Sentinel, we also covered it, I think, in PLD 101. It's been a while. Sentinel, that's what we call a special value that's going to tell us that this is the end of our sequence of items. And another example of that, for example, if we're reading some input from a file, we will know that our file reached the end if we get an empty line, right? If we have the lines, like if we have our file filled with lines of some sort of strings, some sort of sentences, we will know that we reached the end of a file when there's an empty line. So that empty line is going to be our sentinel. It just marks the end of your sequence of items. That's all it does. Now, this you should be fairly familiar with input validation loops. It comes from a concept of garbage in, garbage out, which stands for right here, GIGO, garbage in, garbage out. So input validation loops, all they do, they just check that the user gives you valid input, because your computer will not tell the difference. Your computer does not know which input is bad, which input is good, so you have to check for that yourself. For example, if you're asking your user to enter their age, right, for some sort of, I don't know, for example, for insurance purposes, if you ask your user to enter their age, for example, you want a number. However, if your user will give you a string and you do not have an input validation loop, your computer will not know that this is not a valid input. However, if your user inputs their name instead of their age, that's going to cause a big mess up in your program, and it's just going to make your program to crash. So whenever you're working with inputs, you have to make sure that you have some sort of input validation available there for your computer to use. Yeah, as I said, input validation just stands, it's a concept of inspecting your input before it is processed by the program. So input validation, you're just making sure that the bad input that you don't want never reaches your computer at all. And let me show you what it looks like. So everything that happens here in this flowchart, so we get some sort of input from the user. It doesn't matter what it is. We get some sort of input, and then we just ask a question. Is the input bad? Do we want this input or not? If this input is bad, then we're going to display an error message, and we're going to maybe specify that please enter your name or please enter your age. And then we're just going to get that input again. And it will just keep going until you get the good form of input. After you get the good input, you're just going to keep executing your program. So nothing too complicated there. All right. The walrus operator, again, I'm not going to focus on this just because nobody really uses it, and it's, I don't know, I've never seen in my life anybody use the walrus operator. However, if you're really interested in it, you can just read this slide over. And nested loops. So nested loops, again, you should be fairly familiar with this, but I'll go over it again. It's just a loop inside the loop. All this is, you're just nesting the loops on top of each other. And what that happened, what that does, this is a great flowchart to show you an example of a nested loop. So as you can see here, we start by asking, is there another value in the hours list? Then if there is another value, we're following this arrow. Then we are assigning whatever the next value in the hours list to the hour variable. However, after that, we're not just going back, right? We're not doing this. No, we have another loop. We're coming right here, and then we are asking, is there another value in the minutes list? Because we want to get the hours and the minutes. Now, if it's true, we're gonna go right here, and then we're gonna assign whatever value in the minutes list to the minute variable. And then still, we're not going back. This is not what's happening. We're not going back. We have another loop inside. And then we're asking, is there another value in the seconds list? Now, if it's true, we are assigning whatever value in the seconds list to the seconds variable, then we printing hours, minutes, and seconds right here. And then we go back. So this one will bring us back to right here, to the first loop. However, if this evaluates to false, if our condition right here evaluates to false, it's not ending the execution. The execution of your loop is still going. However, instead of executing the inner loop, we are going back to our outer loop right here. This is where it brings us. And again, same thing works here. This is the inner loop. We're still in the inner loop, and we are checking if this condition is false. Then we're gonna go all the way to the beginning of our program. And this is right here. This is your outer loop, checking for if there are any hours in the list. This is the outer loop right here. One thing you need to know about nested loops is that your inner loop, so there's an outer loop and the inner loop. Your inner loop, will go through all of its iteration for each iteration of outer loop. For one time when your outer loop is executed, all of the executions of your inner loop will be done. So that's all you need to know. And you can calculate the total number of iteration in your whole nested loops. And all you need to do is just take the number of iterations of your inner loop and multiply it by the number of iterations in your outer loop. So again, pretty simple, nothing too complicated. The break statement. So the break statement, all it does, just terminates your loop. If some condition is present in your loop, we're just gonna break out of a loop. This is all that your break loop is going to do for you. It just stops your loop at any given point of time. Wherever you put your break, that's where your loop is going to terminate. Continue statement is the opposite of break. So continue is going to cause your current iteration that you're going through is going to end. That current iteration is going to end, but then you're going to keep going with the new iteration. So the break statement ends your loop as a whole, and the continue statement just ends the iteration of your loop, and you just start going with the new iteration of your loop. Yeah, here's an example. Here's a little example. So we have n equals 0, and then we are checking while n is less than 10, we're going to add 1 to our n. However, if the remainder of n after it's divided by 3, remember the modulus operator, it just checks for the remainder. If the remainder of n while it's divided by 3 equals 0, then we're gonna end that iteration and we're gonna go all the way back to the beginning. So we're not gonna reach the print statement at all. And you can see it right here. So the only values from 0 to 10, they're gonna satisfy this condition right here are going to be 3, 6, and 9. And as you can see here, the list of these items does not include 3, 6, and 9. So we have 1, 2, then 3 is skipped, 4, 5, 6 is skipped, 7, 8, and then we skip 9. And that only happens because we have the continue statement right here. So the print n never, the n never reaches this value right here, this statement right here, print n, it is never reached. That's the only difference between your regular iteration and your continue iteration. All right, you can also add an else clause for your loops in Python. You cannot do that in Java, so this is something new. you can add an optional else clause, and all your else is going to do, it's just gonna, if your loop terminates normally, you're gonna have that else is gonna execute. However, if it encounters a break statement, your else will not execute. So let's look at this again. So what we have here, we have a while loop that sorts some sort of condition, and then we have some sort of statements right here, some sort of code. So we're only gonna reach this else if our while loop does not have a break inside of them, or if we don't encounter a break. That's a better way to say it. That's all you need to know. If we encounter a break, your else will never be executed. Here's an example. So for n in range of 10, and remember, if we only have one argument in our range function, that just means that 10 is going to be our last number that we need to go. This is going to be a sentinel. It's going to be our 10. If n equals 5, we're going to print breaking out of the loop, and then we encounter a break right here. However, we also have an else that's going to print after the loop n is whatever the value of n is. So in this case, let's see what this program is doing. So we'll start at 0 because that's the default if you're using just one argument for your range. We're going to start at 0 and we're going to print n. So because n is not equal 5, we start at 0 and does not equal 5. So all we do, we skip this if as a whole and we just print our n, which you can see right here, 0. We printed 0. And we keep going. 1, 2, 3, 4. So we print all of these, then we reach n equals 5. So this statement is executed, print breaking out of the loop, and then we just break. As you can see here, breaking out of the loop, and then nothing else is printed. So we never reach this else at all. But let me show you the example of when we reach the actual end. For n in range of 3, so the difference, we have 10 here, we have 3 here. If our n equals 5, so it's the same loop, the only difference is our range is 3, and in this one, the range was 10. So what we're doing here, we're starting at 0, so we're going to print 0 right here, then we're going to print 1, we're going to print 2, and then when we have 2, we are going to come in here and we're going to see n equals 5? No. So we skip the if as a whole. We print our n, which is 2, and then we go to our else statement because our loop never encountered a break. We go to our else statement and we print after the loop n is whatever the value of n is, and you can see it right here. After the loop, n is 2. All right, so this was everything I had for today.